Imagine pouring every ounce of your physical passion into an instrument, slamming the keys with everything you have, only to hear the exact same delicate volume as if you had barely brushed them. That was the reality for musicians 300 years ago. The reigning champion of the musical world was this, the harpsichord. It was a beautiful piece of machinery, but it had a severe mechanical limitation. Because it produced sound by plucking its strings, it had absolutely no volume control. Composers and players were trapped in a dynamic flatline. They could write intricate melodies, but they couldn't use volume to express a sudden burst of anger or a quiet moment of grief. To see why they were stuck, we have to look past the ornate wooden casework and examine the engine inside. Here is a schematic of a standard harpsichord key and string. A plucking mechanism is a binary switch. It is either on or it is off. You can barely tap the key or drop a brick on it. The internal mechanism travels the exact same distance to snag and release the string. The input force does not matter. The acoustic result is the exact same output every single time. A strict engineering bottleneck, rather than an artistic preference, dictated how early music was written and played. That bottleneck persisted until 1709, when an Italian harpsichord builder named Bartolomeo Cristofori started working on a solution. Cristofori realized that if he wanted to give musicians control over volume, he needed to change how the string received its energy in the first place. He decided to completely abandon the quill plucking mechanism that every other builder in Europe was using. Solving the volume problem required throwing out the accepted standard entirely and building an entirely new mechanical pathway from scratch. Cristofori's breakthrough was replacing the tiny plucking quill with a series of small hammers. Looking at this side-by-side comparison, we have the old harpsichord mechanism on the left and Cristofori's hammer on the right. While the quill rigidly catches and releases, the hammer is unattached to the string. It swings freely in an arc based on momentum. This creates a direct proportional relationship. The speed of that hammer through the air is dictated by how hard the musician strikes the key. A faster hammer strikes the string with more kinetic energy, driving a wider vibration into the wire, and a wider vibration directly translates to a louder acoustic volume. By swapping out a rigid binary switch for a proportional mechanical lever, Cristofori successfully engineered touch sensitivity. Because of this capability, Cristofori named his 1709 invention the gravicembalo col piano e forte, literally a harpsichord with soft and loud. Over the years, players and builders refined the design, and history eventually shortened that long title to simply the piano. For the first time, a keyboardist could shape a melody with subtle acoustic contours, dropping to a whisper or rising to a roar with just the pressure of their fingers. This massive expansion in dynamic range made the piano the new standard, and it quickly rendered the harpsichord obsolete. Composers quickly took advantage of the technology, writing pieces that relied on dramatic swells and sudden drops in volume to carry emotional weight. Bartolomeo Cristofori didn't just solve a mechanical volume problem.